Hello guys, you're welcome back to Crypto Tech Coders, and yeah, so we're gonna be dealing with a simple shell. So basically, it's gonna be like a series, a daily series, and because some days I have time, I have to go. I don't have time, I have to go to work, and some days I have time, so I have to break it down. So today I'm already late for work, but I know it's day two already, so I'm going to tag this as day one. So I'm going to kind of explain some concept to you. So everything we need to know to start coding our shell, I think this would help. This resource provided by Alex, right? So I'm going to be explaining this resource to you in a simpler term, and by the time we are done with this, tomorrow is Friday, so by Sunday, I think I will have more time, so we'll be done and we'll have brush up this guy, and then we'll be ready to explore the shell, right? So we have what we call PID and PPID. So PID is just what we call process ID, as you can see here. Process ID, and PPID is like the parent process ID. So let me grab my notepad and use that because I might need that, because you need to obviously understand this concept and have the mindset that it is a very simple task to do. If you have that, I think it's going to help as well. Let's open. My system might be delaying for a while, so bear with me. Okay, good. All right, so we have what we call process ID, right? Did you open twice? Okay, so if you look at it, it says let me click on this. It says a process is an instance of an executing program that has a unique process ID. Okay, let me explain it in this term. Is that when you have an executing program, right? So in let's say in the memory or something, they have a table. Can I have a table here? I'm not sure. Okay, so if this is row one, let me increase this guy. Okay, so if this is row one, we have row two, we have the row three. Imagine these are tables. Okay, so your computer can keep track of each executable files, right? So it can keep track of it, and then it gives it a process ID. Okay, that okay, I'm trying to add a number and I've executed it, so it will give it an ID. I think the ID is basically, I think, four or five numbers, so we can have like 6754, right, as a process ID. We can have this as a process ID. So each execution you are doing has a process ID. So this one, let me just do it this way. So this one can be 6755. Okay, so the next process ID will be 6756, right, like that. Okay, so each execution is having a unique ID. Okay, so a process is an instance of an executing program that has a unique process ID. Okay, so this process ID is used by many functions and system calls. So so your a function can call this process ID and know that, okay, it is this guy I want to execute, right? So let's say this is one execute one. Let me put it together. Execute two, like that. Execute three. Okay, like that. So it knows, it can call this process ID and knows that I want to execute this, I want to execute this, I want to execute this. Okay, so that's that. So in order to retrieve the current process ID, so if you want to know the current process ID you are in, you use this function called get process ID. Okay, it's as simple as that. So let us man get ID. getpid rather. So is it man2? I think most of these things are man2. Get process id, right? Okay, so it's get process identification, right? So when you are doing it, you include this header file system types.h, right? And UniSTD. This one is for UniSTD talks about all system calls, right? System calls are what makes your your program um, execute command from the computer itself, right? From the kernel directly, right? So that's what this guys does. And then so damn, I'm so sorry. Okay, so we have to get process id, right? So what thing you should know is that they are stored in this pid_t. So we have get pid process id, and we have get parent process id. Okay, so we'll know the difference between this. Okay, so let's see. We have get pid, right? And we have get process id. So they are two different though they are used to get process ids. Okay, both are used to get process ids. Let me close this. Okay, so yeah, so they are stored in this pid_t. Pid_t holds some integer, but they are for process id integer, right? Okay, so we have the process id. It returns the process id of the calling process. Okay, so it will return a process id, right? So this one will return process id of the parent of the calling process. So this one is the parent process id. We will understand what parent is and what child is. This one they are called child, right? So we'll understand what they are later. This will be either the id of the process that called this process using fork. Okay, so one thing you should know is this fork. Okay, I think we'll still get there down, right? They explain fork for us. So fork basically is to duplicate and is to create another id, right? So for example, let's see. So if I fork this id right now, right? If I use fork, I'm not forking it. I'm just saying. All right. So if I use fork on this id, it's going to kind of create a duplicate process id, which is called a child process id. With that child process id, so it's going to create a child process id. So let's call it child execute 1. Okay, so it's going to create it, and it's going to have its own process id number, right? So it can be, let's say, 6777. Okay, so it has this number. So this one is executing something, is going to go through one particular pattern. Maybe it want to add number, it will first add this and then do another thing and then do another thing. This child execute 1 will also follow, is also doing the same thing this guy is doing. So we are making two different things. Okay, we are making two different we are making a program is executing something, so we are making it execute it in two different places. Okay, so we have a child and we have this parent. Okay, so if you want to get id of the parent, you can use get ppid. If you want to get id of the child, you can use this guy. So with this, we can use it to manage, to make our program multitask and say, okay, let this guy do something else and let this guy do something else. Okay, but by default they are both doing the same thing. Okay, so that is what this guy does. All right, so let me see. These functions are always successful. But normally, yes, I think they are always successful. Let's see. Are there more things to know? Okay, for now, let us leave that for now. The concept man2, great. So if we look at this program, so we are going to execute this program. I'm going to create a stuff on my shell. Sorry, I'm going to create a stuff on my shell, and someone is calling me. Make directory, and I'm going to call it. Please hold on a second. Sorry, thank you. I'm going to call it shell, right? Okay, so I'm seeding into my shell, or let me call it, I don't know, I think probably the one we'll be doing would be shell. So let me call it shell is it move directory, shell to shell tutorial, right? So we'll seed into our shell tutorial. Okay, good. All right, so one thing I will do is I want to create that file, so we'll see what happens to that file, how that file gets process ID. Okay, so it's called ppid.c. so we'll copy this guy, right? vipid.c, paste it, right? So if you look at it, okay, so pid underscore t is used to, is like an integer. So see this thing as if it is an integer and this is the variable name. So this is a variable, right, storing PIDs, but this is the variable name. Okay, so we want to store something inside this PIDT, right? So we now say my PID, right, is equal to get PID. So we are getting PID of this program, right? We are getting PID of this program and we are saving it into this my PID. Okay, and my PID, because it is PID underscore t, can receive PID numbers. So by the time we print it, my PID, we'll see what it will get. Okay, so that is what this guy does. So we'll compile it. I think we use GCC wall blah blah blah. So this one is compiling and running at the same time. As you can see, it says pid.c, the output should be my PID, and run it. Okay, so let us run it. So by the time we run this guy, the process ID, on their system is going to be different. My own is 1852. It is 4 numbers, right? If I try and execute it again, because this the process ID, if it is a table, right? If this thing, I think I would have loved to use so if this place is a table, right, and it is 1852, it means that place is the process ID, right? This place is the row 1. So the next row, let's say this place is 1853, 1854. So each time we execute this my PID, is going to have, as you can see, it increased, right? Telling me that the process ID of that execution I did before was here. Why do these people keep making noise? What type of people is this? This is Nigeria, crazy country. Alright, so damn, this noise is too crazy. Please hold on, let me close my windows. All right, thank you. So basically that's it. The PID is, as you can see, is consecutive. That is, this role has done this thing before. Like the process ID was here before, right? So is like a kind of memory stack, right? Where I wish I can get my table. Okay, so we can't get table here. Okay, so I just hope you kind of get what we're doing. So if you have a table, right? So the process ID for that first execution was here. The second time the process ID was here. The third time the process ID was here. You see? So the process ID, so we can refer to this number and use it to do so many things. Okay, so the process ID of this one would increase like that, and that's just what they're explaining there. Okay, so basically let's go through it one more time. It says a process is an instance of an executing program, right? Executing program that has a unique process ID. So the executing program has unique process ID, as you can see. This process ID is used by many functions and system calls. So they are using that process ID to interact with and manipulate processes. So they are using that process ID to interact and manipulate processes. In order to retrieve the current process ID, you can use this process getpid, right? Okay, and then when they execute it, as you can see, like that, like that, like that. So the process ID is increasing. Note in the example that every time you run the program, a new process ID is created and its ID is different, right? Each process has a parent, like I was explaining, and then the process that created it. It is possible to get PID of a parent process by using getppid system. So use this guy to check it from within the child process. Okay, so so when we man get ppid, okay, so it's still the same. We have to include our system types .h, this guy, and it's almost like the same for p get pid, as you can see, get pid, right, that we did. Okay, so I don't know, I mean, I don't want this video. So we have one exercise for this guy. So he says that get ppid, write a program that will print the ppid of the parent process. Run your program several times with the same shell. It should be the same. Does echo this, print the same value, and the y. And then we have another one. This guy, write a shell script that print the maximum value of a process ID can be. So in the next video I'm going to be doing this because there's a lot of noise here and I'm running out of time. Okay, so in the next video we're going to do this exercise. Okay, so stay tuned, and this is going to be like a series, so you'll be able to follow through. See you.